Hello, my name is Majd Dalgamdi. Today I will be explaining the second exercise using SAS Enterprise Miner. So let's get started. Well, as you can see here, I have already created the models. So I import my data from here. Then I went to the variables because there are some changes we have to do with my variables. So before we get to that, let me explain my data set. My data set is the Titanic data, and as you can see here, the number of siblings and spouses, the number of parents and children, ticket number, and also the passenger class. We have three different classes. One is first grade, two is second grade, and three is third grade. And the amount they are paying, and also the port implication. We have also three different places where each passenger departed from, and as you can see, we have like shortcut of each place S and C, then Q, and then our target variable is the survival. Let's go back now. I did some changes and I set up the survived as my target variable, and also I changed the level. Instead of interval, I put binary because we have two different values, 0 and 1. We can explore our data and visualize it before we build our models. So click explore. Basically, these graphs tells us the distribution of our data. Here the number of males on the ship, there were like 577 of males, while the number of females was less than the number of males. And here under age comes my first concept. This is a large fraction of missing values under the age input. So we understand that we have 177 of missing values before we go any further, so we can deal with these missing values. All right, data partition. We partition our data to 60 for training, 30 for validation, and 10 for the test. I created the control point. Instead of making many manual connections between multiple models, which is time consuming, a control point will simplify the process flow diagram. Then I created three different decision tree models. So the first decision tree, I increased the maximum branch to 10, the maximum depth to 9, and the leaf size to 10. And the interactive decision tree, I went to interactive and I built my tree based on the most important variables. The last decision tree, I decreased the maximum branch to 2, the maximum depth to 6, and the leaf size to 5. The first decision tree, 6 is the most important variable. We have 9 nodes, so our important node is 6. When you look at female, there are 25% of the female didn't survive and 74% of them who survived. For the second decision tree, we have almost the same thing. Our important variable is 6, but the tree here seems larger than the first decision tree. And now I will compare both decision tree 1 and decision tree 2 by looking to the outputs. So for the first decision tree, the false negative is 80 and the true positive is 124. We are talking about the train. And for the second decision tree, the false negative is 66. So instead of 80 in the first decision tree, our false negative is decreasing, which is good. And for the true positive, instead of having 124 with the first decision tree, we are looking for 138, which is good. And here comes my second concept, which is if someone feels that the confusion matrix is hard, we can look at the overall accuracy. And here's the way I calculate it. By looking to first decision tree, I added up the true positive and true negative together and I divide them by overall. So I got here 78% for the overall accuracy, and for the second decision tree I got 81%, which is better than the first decision tree. Then I created impute here, and here comes my third concept. So the reason why I am imputing my data here is because we have a large number of missing values, and neural network and regression, both, they ignore any missing values in our table. If you think about it, if we have like 200 passengers and the models here get rid of 177, then why would I need to build a model? Someone might ask why decision tree doesn't need imputation, and here comes my fourth concept. When a decision tree can handle missing values, and to prove that under Node there is a feature that called number of surrogate, and the number of surrogate roles attempt to deal with missing values by substituting them with other values. Then I created the first neural network, and I did nothing with the property. I just run the model as it is. So I came up with the results. The number of iteration is 5, as you can see here, and the outcome when we look at the misclassification rate is 0.17. So here comes my fifth concept. Because the number of errors is so high in our network, and it takes so long to train our data, we can come up with a better solution using backpropagation technique. This technique uses a set of weights that results in few errors and can reduce the iteration length. I went to optimization, so I changed the technique here to backpropagation. So I run the model and I got this result. The number of iteration is 0, as you can see here, and the output, instead of having the misclassification rate 0.17, now it decreases to 0.16, which is good. Finally, I compared all the models here. So let's first look at the ROC chart, and by looking to the information below here, the neural network 1 is the purple color and yellow is the neural network 2. And by looking to the ROC chart, we can see purple is the highest one, so that means our neural network 1 is superior. And here comes my concept 6. Some users might say this is not a good way to judge the data because there is ambiguity in our data. We can look at the fit statistics. By looking to the misclassification rate, we have the lowest misclassification rate with neural network 1, which is 0.14, and we have different statistics that we can look at and judge our data.